we're now looking at target 2. I can factor trinomials with a leading coefficient of 1 and difference of squares. So, we want to know what factors are and what factoring is. So factors are numbers or expressions that multiply to the given expression. Okay, so I'm going to go scroll back to what we looked at yesterday, right? We were doing all this multiplying yesterday. So basically what we're doing is if I'm given an expression like this, and we're really going to do the binomial ones today. So we'll look at here, right? Here, I'm multiplying to get to here. So these two are factors of this expression, because when I multiplied them together, that's what I got. Sorry about the bell. Okay, so then factoring is simply finding those numbers and expressions. Okay. So before we get started, I want to do 2 multiplication problems and kind of think about where these numbers come from when we have just no coefficients in front of our x's. It's a little bit easier to see how the things all go together. Okay? So, we have x squared. Nope, not what I wanted to do. Sorry. X squared minus 3x. And then we have 5x minus 15. So our final answer is x squared, negative 3x plus 5x is plus 2x minus 15. Okay? So really what I want to know is where these 2 numbers came from, this 2 and this negative 15. When we start with 5 and minus 3. Okay? Well, if you look, I had the negative 3 and the 5. And I just added them. So this 2 really came from negative 3 plus 5. And this negative 15 came from our negative 3 times 5. The order doesn't matter for these. 5 plus negative 3 or 5 times negative 3 would still be the same thing. Okay? Well, let's see if it happens again. Right, figuring out a pattern. All right, so then we have x times x is x squared. X times 8 is 8x. 2 times x is 2x. 2 times 8 is 16. So yes, we have x squared plus 10x plus 16. So again, this middle number, this 10, right, came from the 2 plus 8. And this 16 came from the 2 times 8. Positive 16. Okay, so we're going to use this idea now in reverse. So we're now going to look at factoring these expressions. Well, this first one should be easy. Okay, what we do is we're looking for two numbers that are going to act that way, right? Our middle number is addition, and our last number is multiplication. Okay, and we need to find the two numbers that are going to do that. So I like using the X method. I put my middle number on top, and I know I'm going to add to that, and my last number on bottom, and I'm going to multiply to that, and I'm looking for my two numbers that do this, and I'm going to fill them in here. Okay, so what numbers add to 10 and multiply to 16? Well, 2 and 8, since we already saw those, right? 2 plus 8 is 10, 2 times 8 is 16. Okay, so now we know with x squared we need an x, and then plus 2, and another x plus 8. Okay. And there we have factored it. We've taken it from the first expression and factored it into the two expressions that I multiplied together. Okay. This is a review from last year. So if you kind of remember this, that's good. Looking at our next one, x squared plus 10 plus 9. Same thing. I'm going to put an x in that. We're missing one. It's positive 10. That's what we need to add to. And then positive 9, I'm multiplying to. Okay, and now it's just guess and check, right? That's really what all this is. So what are things that multiply to 9? Well, one of the first things that comes into my mind is 3 times 3. But if I put a 3 and a 3 here, 3 plus 3 is not 10. So I have to think of another multiple. So 1 times 9 . 1 plus 9 is 10. 1 times 9 is 9. Always do your multiplication first, right? Infinite number of things add up to 10. Okay? So always think about your multiplication first. Order does not matter. I could put this as x plus 9 and then x plus 1, and that is fine. All right, looking at part C, a squared minus 6a plus 9. So it doesn't matter that it's an a now instead of an x, but that's okay. So now I am adding to negative 6. Switch colors, sorry. And we are multiplying to 9. So now again, I can think 3 times 3 and 1 times 9 are my factors of 9. But none of those are going to add to negative 6. So we do have to be careful. 3 and 3 add to positive 6. But I want negative 6. So you have to start playing around with negatives. Okay, so you have to be very comfortable with positives, negatives, and your multiplication rules. Negative times a negative is a positive, so negative 3 times negative 3 is still 9. And then negative 3 plus negative 3 is negative 6. So I have a minus 3 and a minus 3. Looking at part D, x squared plus 7x minus 30. I'll switch back to my colors I was using previously. Positive 7 is what we're adding to. Negative 30. is what we're multiplying to. So what are two numbers that multiply to negative 30 and add to positive 7? Well, if I'm multiplying to negative 30, right, if I'm multiplying to a negative, that means one number is positive and one number is negative. So, there's lots of different numbers I can think about. The first one that pops into my mind is a 3 and a 10. If I play around with positives and negatives, if I make, let's say, I don't know, when I make 10 negative. Well, 3 plus negative 10 is negative 7. I don't want negative 7, I want positive 7. So I'm going to switch the sign. Negative 3 and positive 10 would give me positive 7. Okay? Again, a lot of it is guess and check. You might have to try a few different things before you find the two numbers that work. As you keep doing it and keep practicing, they'll come easier. All right, part E, y squared minus y minus 6. Again, there's a 1 in front of this y. Well, negative 1. So we have negative 1 is what we're adding to. Negative 6 is what we're multiplying to. Okay, so things that multiply to negative 6, well, that's 1 and 6, and 2 and 3. 2 and 3, I think, is going to get me closer to 1, right? Or get me a 1 somehow. And I'll get a negative 1 by making the bigger number negative. So 2 and negative 3. So that's y plus 2, y minus 3. Last one. We are adding to negative 10. Oh, wrong color. And we are multiplying to 25. Sometimes your numbers that you're multiplying to are easier because the only things that multiply to 25 are 1 and 25 and 5 and 5. So 5 and 5, and then again I want a negative, so I'm going to make them both negative. Alright, so that's it for what I call your basic trinomial factoring. The next thing we're going to look at is difference of squares. Now, difference of squares is of the form a squared minus b squared. Okay, before we move on, we're going to look at example 3, where we multiply the following. If I have x minus 5 times x plus 5, I have x times x is x squared. X times 5 is 5x. Negative 5 times x. And negative 5 times 5. So when I get my answer, I have x squared. Well, this is nice. I have 5x minus 5x. Those go away. And I'm left with x squared minus 25. This x squared came from x times x. This 25 came from the 5 times the 5. Right, well, negative 5 times positive 5. Okay, so this is this difference of squares. A number squared, I could think of 25 as 5 squared. Same thing for part B here. X times x is x squared minus 11x. Minus 121, and we get x squared. Again, these are the same but opposite. So if we're thinking about the opposite way, if I'm given something like this, it's the same as A plus B and A minus B, right? Well, if this is A squared, then A is just X. 25 is 5 squared, so it's just 5, right? And the only difference is there's a plus and a minus between them. It doesn't matter which one has the plus and which one has the minus. Okay? They can, again, by commutative property, they can go in any order. Okay? So, how we do this problem, the easiest way I think of for the work for this problem is making sure you know it's a difference of squares. We are pretty good at knowing our perfect squares, so that's good. And then I just draw a nice little square root over them. So the square root of x squared is x. The square root of 25 is 5. One needs a plus sign. One needs a minus sign. Same thing here. That's x plus 10, x minus 10. So these are nice and quick. Now here, same thing, but we have that number out in front. Well, 9n squared, it's just, think of doing it twice. The square root of 9 is 3. The square root of n squared is n. Plus 8. 3n minus 8. Same idea here. Square root of 81 is 9. Square root of j squared is j. Ooh, and now I have a k squared. Well, the square root of k squared is just k. So it doesn't matter that I have multiple variables, right? It's still the same idea. Just taking the square root of both of those. These are nice and quick. All right, same thing here. Be very careful when, right, of the order, because subtraction cannot be switched, okay? So the square root of 36 minus y squared, right, or 36 minus y squared, if I take the square root, I have 6 plus y and 6 minus y. This is not the same as y minus 6, okay? I cannot switch subtraction. So it has to be in the same order. Last one, 1 minus b to the 8th. Well, the square root of 1 is just 1. B to the 8th. When I take the square root of exponents, you're just cutting the exponent in half. So if I have b squared and square root it, that's b. If I have b to the 4th and I square root it, that's b squared. If I have b to the 6th and square root it, is b to the 3rd. So this number is getting cut in half. So if I have b to the 8th and I square root it, that's b to the 4th. Right, and it makes sense if we think about the opposite direction. When we multiply, remember we add our exponents. So b to the 4th times b to the 4th would give me b to the 8th. And that is it for today. I will see you guys tomorrow. Have a great rest of your day.